Hello everybody and welcome to another YouTube video. So in today's video, what I'm going to be doing is showing you how to create a Microsoft Paint-like program, kind of a simple drawing program in Python using the module known as Pygame. Now don't mind my cat here, you're probably going to hear her in the microphone to be honest, but regardless, I'll just give you kind of the prerequisites and give you a little bit of a demo of what this tutorial is going to kind of show you how to make. So you can see here that you can just change your pen color or your stroke color, whatever you want to call it. You can kind of draw just like you would in any other kind of pixel art like program. You can erase, and then of course you can clear. So pretty straightforward. The idea being that I'm going to give you a good solid base, and then you guys can add on to this. You can add different colors, you can add different buttons and different functions. Pretty easy to do that once you have a solid base done. Now, in terms of prerequisites, you should have some familiarity with Python. Don't need to be a master, obviously, but just maybe worked in Python a little bit before. And you do not need to know Pygame, which is the module we'll be using here for the graphics to follow along with this video. If you do want to learn that beforehand, great, that will definitely help you. I have a bunch of other videos on my channel that are dedicated to Pygame. Here, I will explain to you the Pygame features that we use, but that's not going to be the core purpose of this video. So with that said, let's go ahead and dive in after a quick word from our sponsor. Before we get started, I need to thank the sponsor of this video, which is AlgoExpert. AlgoExpert is the best platform to use for preparing for your software engineering coding interviews and has the highest quality coding interview practice questions. With 160 practice questions, detailed solutions in 9 of the most popular programming languages, a feature-packed browser-based coding environment, extensive test suites, and conceptual overviews and code walkthroughs for each and every problem, AlgoExpert is the best resource to use to ace your coding interviews. AlgoExpert also has a data structures crash course, coding interview assessments, and a mock interviews feature. I can highly recommend AlgoExpert as a former customer myself and now an official instructor on the platform. Get started using AlgoExpert today by clicking the link in the description and using the code TechWithTim for a discount on the platform. All right, so let's go ahead and get started. The first thing I'm going to show you how to do is to install Pygame. That is the library that we'll be using to do all of our graphics. If you already have Pygame installed, just skip forward in the video. You'll see some timestamps in the video player. So to install Pygame, what you need to do is open up your command prompt or terminal if you are on Mac and type the following, pip install and then Pygame like that and hit enter. For me, this is already installed, so it says requirement already satisfied. Now, if for some reason this command does not work for you, try the following, pip3 install Pygame. And if that one does not work for you, try python-m pip install Pygame. If that doesn't work, try python3-m pip install Pygame. And if none of those work, I have 2 videos on my channel, which I will link in the description, that show you how to fix this pip command, one for Mac and one for Windows. All right, now before we dive into the core of the code here, I just want to show you that I do have a friend here sitting on my desk. So if you notice that it's hard for me to type, that is because, of course, my cat wants to sit right in front of my keyboard. I'm sure if you guys have cats, you have to deal with that too. Anyways, let's go ahead and get started. So I'm using VS Code for this tutorial. You can use any text editor that you want. You can use the default Python IDLE, but we are going to be working in multiple files here. And that is because I want to show you how we can kind of split up and section our program so that it's easier to read and we don't just have a ton of code in one file. It's a good practice and it will kind of teach you a little bit about how to import modules and, just structure a code base. I figured that would be valuable for you guys. Anyways, the first thing we're going to do here is make a file. I'm inside of a folder in VS Code. I'm going to call this one main.py. All right, so let me zoom in so you guys can see this a bit better. We have main.py. Then I'm going to make a folder. I'm going to call this folder utils, and this folder is going to represent a Python package. That means inside of here, what we need to do is put __init __.py. Whenever you create this file, so it has 2 underscores, init, 2 underscores, .py, and you put that inside of a folder, Python is going to treat the folder that file is inside of as a Python package, which means from main.py, what I can actually do now is I can import the utils folder. So that's cool. If you don't have init in there, you can't do that, but we can because we have init inside of that folder, which makes it a package. Anyways, I'll kind of explain more about how that works in a minute. But what we're going to do now is go inside of utils and we're going to make 2 new files. The first one is going to be settings.py and the next one is going to be button.py. Now, button is going to store a class that will represent a button that we are going to use on in our program. And then settings.py will have all of the settings for our drawing application This way, if we want to change anything, we can just come to this one file, settings.py. We don't need to look through a bunch of code, and we can see all of the core settings that we have. So we'll actually get started inside of settings.py. Remember, we've got Pygame installed now, and I do kind of have a cheat sheet on the right-hand side of my screen. So if you see me referencing that, that's what I'm doing. And inside of settings.py, what I'm going to do is I'm going to import Pygame like that. Okay, so we're going to start by importing Pygame. We're then going to initialize Pygame. So pygame.init, and then pygame and this is going to be font.init. So these are kind of the first two things you do. You need to always initialize Pygame after you import it. And then if you're going to use fonts, which we will because we need some text for our buttons, specifically clear and erase, we need to initialize the font library package module, whatever it's called, within Pygame. Next, what we're going to do is define a bunch of different colors that we're going to use for our game. So we're going to have white or program, game, whatever you want to call it. Anyways, white is going to be 255, 255, 255. So in Pygame, we use RGB values for all of the colors. So red, green, blue. White is simply all red, all green, and all blue. So 255, 255, 255. We then are going to have black. So black is going to be 0, 0, and 0. We will then have red. Since it's red, green, blue, we're going to have 255, 0, 0. We'll then have blue. This will be 0, 255, and 0. And then we will have green, which will be 0, 0, 255. In case you were wondering, the scale for all of the values here goes from 0 to 255. So if you put 255, that means, all red, all blue, all green, respectively. All right. Now we have our colors. The next thing that we're going to define is the frame rate for our game. We're just going to make this a standard 60. You can experiment with this if you want, but just make it 60. That's usually what I use for all of my games. You'll see where we use these variables in a minute as well. Let me actually make this full screen. Next, we need to define the width and the height of our window. So our actual window for our game needs to have a width and height, obviously. So we need to pick what that's going to be. The width I'm going to go with here is 600, and the height is going to be 700. Now, in case you're wondering why I'm putting all of these in capitals, it's because these are constants. So in Python, whenever you have a constant value that is not going to change, you put it in all capitals, and that just kind of represents a constant. It's just good practice. Now, why are we making the height slightly larger than the width? That is because we want to have a little menu bar at the bottom of our screen. And so we'll have a canvas that's 600 by 600. That's kind of the drawing area. And then we'll have 100 pixels. That's the extra height for the actual kind of toolbar at the bottom. Okay, next what we're going to do is say rows is equal to calls is equal to 50. So what we're actually going to have here is a bunch of individual pixels, right? You saw when I was drawing, and in fact, I can rerun this program here. So notice here how it's like one pixel at a time. Since we're going to have all of these pixels, we need to define how many of them we're going to have and kind of the size of each of these pixels. And that's what rows and calls is going to do. So we could make this more rows and more calls so long as they're square, and then the size of our pixels will be smaller. So I'm going to go with 50 for now, but you can make that larger, smaller, whatever you want. And we'll experiment later once the program's done with different settings here. Okay, next. After that, what we're going to do is define the size of our toolbar. So we're going to say the toolbar height is equal to, and this is simply going to be the height minus the width. So whatever the difference in the height and width is will be the height of our toolbar. Then we're going to say our pixel underscore size is going to be equal to our width integer divided by our rows or by our calls. It doesn't really matter which one we use here because this is going to be a square canvas. And the reason we're doing this is we want to know what the width and height of all of our pixels are. That will be represented by pixel size. So obviously we know how large to draw them. Okay, now we have pixel size. Next thing we're going to do is our background color. So the background color by default is going to be white, but you could change this if you want the canvas to be black and maybe you're drawing white on it. You could totally do that. You would just change this to be black. Okay, and then finally, we are going to do one more thing. This is going to be draw underscore grid underscore lines, and this is going to be equal to false to start. If we want to actually draw the lines that show us where all of the pixels are, then we would make this true. And I'll show you what that looks like again later. Okay, last thing we're going to do, it's not going to make much sense right now, but we're just going to put it in so we don't have to come back to this file, is we're going to define a function, and we're going to call this get underscore font. This is going to take a size, and what this is going to do is return to us a font object that has a specific size. So we're going to say return Pygame .font.sys font like that. We're going to put in the name of our font. I always use Comic Sans just because you guys think it's funny. And then we're going to put size here. So what this will do is generate for us a font that is Comic Sans that has size of whatever size it is we pass to this function. We will use that later on. Perfect. So now we have finished the settings file. We just need to do that first so we could use all of these variables from within our main.py script. Now what we need to do, though, is we need to go to init.py. And what we're going to do inside of here, is actually we're going to steal all of our Pygame stuff. We're going to steal all of that. We're going to put that inside of here. And then from .settings, import asterisk. Okay, so I'll explain what this does. But essentially what we're doing here is in our initialization script here, so init.py, we're going to import everything from this settings file. So when you do from something import asterisk, that imports everything. So typically you would do something like import settings, and then let's say I wanted to access the white variable here. What I would need to do is say settings.white, but since I don't want to prefix everything with settings, what I'm doing is just importing every single thing. So usually you do something like from.settings import white, and then you could just use white directly. When you put the asterisk, it's going to import everything. Now the question here is, why do I have this dot? Well, the reason I have this dot is this is what's known as a relative import. So I'm importing a package or a module that is within the same, I'm importing a module that is within the same package as this init script. And so whenever you're inside of a package and you're importing different modules are the individual files, packages are the folders, then what you need to do is use the dot beforehand to say, hey, in this folder, the current folder that I'm in, that's what the dot means, import the settings module, and from that, import everything. Now, the point of doing it inside of this script is that now what I can do is I can say from utils import star, and since in this initialization script, I import all of the stuff from settings, when I do this, this imports everything from settings as well. So now inside of here, I can use the white variable, I can use the black variable, and there's no problem. I can use that. You can see it's actually finding it right here. And that's again because of what I just explained. We're importing stuff in this init script, and then from here, when I import this package and I import everything from it, it runs this script right here, imports everything, and then we'll have access to it in main.py. Now we'll come back to button.py later. For now, though, let's get started in main.py. Now, I am just going to import Pygame in here just so I don't get errors saying like Pygame isn't defined. Although, actually, I'm thinking I might not even need that. Yeah, you know what? I'm not going to do that right now. Okay, the first thing I am going to do, though, is I'm going to define my window, my Pygame screen. The first thing you need to do when you are working in Pygame is you need to set up a window, some type of surface that you can draw stuff onto. So I'm going to say win is equal to pygame.display.set_mode. And inside of here, I'm going to pass a tuple that contains the width and the height of my window. So this is how you initialize a window, pygame.display.set_mode, and then you pass the width and the height. Keep in mind here, this width and height is coming from the settings.py file that we made. Okay, now what I'm going to do is I'm going to set the caption of my window. So I'm going to say pygame.display.set_caption, and we will just say drawing program like that. So we're just changing the little name that's going to show up on the top of the window when it's loaded. Sweet. So now that we have this, what I'm going to do is just set up my very basic event loop. I'll explain what that is in a second. Then we can just start actually testing out the program. So I'm going to create a while loop here. I'm going to say run is equal to true. I'm going to say while run. And then inside of here, what I'm going to do is the following. I'm going to say for event in, and this is going to be pygame.event.get. And what I'm going to check is if the user has quit the window or if they have pressed the little X button. So I'll explain why we're doing all this in 1 second, but let's just get these few lines down, then I can go through everything. So we're going to say if event.type is equal to pygame in all capitals quit, then what we're going to do is say run is equal to false. And at the bottom of our program, we'll say pygame.quit. Okay, so let me explain this. Whenever you create some type of game, what you need is an event loop. Now, the event loop is something that's going to continually run until the game ends. This makes it so that when you load your program, it doesn't just show one frame of the game or one frame of the program or whatever it is that you're making and then immediately end. So in this case, we're creating a while loop, and this while loop is going to end whenever the user presses the X button on our window. So that's what these 3 lines are doing right here. We're saying for event in pygame.event.get. This is a list of all of the events that occur. So we're going to loop through all of the different events that are occurring at any point in time. Pygame obviously gives those to us. We're going to say if the event type is pygame.quit, which means we press that little X button, we're going to set this run variable equal to false, which means this loop will stop, which means we'll eventually hit pygame.quit, and well, we'll be good. We will quit the program. All right, so let me save this, and let's just go ahead and run this and see if we get anything. Okay, so I pressed run. No module named Pygame. Okay, I just need to fix something here. So you can see it's ran the window for us. It's the size that we set it at, and now it says drawing program at the top of the screen. And if I press X, boom, we're done. We don't get any errors. That is exactly what we wanted. All right, so the next thing that I'm going to do here is I'm going to set the speed of my event loop. So right now, at this current point in time, this while loop is going to run as fast as it possibly can. So if you have a really fast computer, your drawing program is going to run faster than someone on a very slow computer, because we're not limiting how quickly this loop is running. We're just saying run as fast as you can, just like any other while loop would run. If you run a while loop that counts up to 1,000,000 on a slow computer and you run on a fast computer, the one on the fast computer obviously is going to happen faster, right? So in this case, what we want to do is kind of limit or set the frame rate of our game so that this while loop is not running infinitely super fast. It's running at a set speed. And that's why we implemented that kind of FPS variable you saw inside of settings previously. So how do we do that? Well, the way we do this in Pygame is we set up a clock. So we're going to say clock is equal to pygame.time.C clock. And then what we're going to do is inside of our while loop, we're going to say clock.tick, and we're going to put our FPS. Sweet. So now what's going to happen is every single time we're inside of this while loop, it's going to make sure we're not running faster than 60 frames per second, or 60 iterations of this while loop per second. Perfect. Okay, now we've got that. So we have our basic event loop set up. The next thing we need to do is we need to actually draw some stuff onto the screen, because obviously right now it's just a black screen. Not very exciting. Let's draw something. So I'm going to define a function here. I'm going to call this draw. And what this function is going to take is a window, and it will take some other things later, but for now, it will just take a window or a surface to draw stuff onto. Now inside of this function, what I'm going to do is I'm going to say win.fill. Now what this does is fill the window with a certain color. And I'm going to fill it with my background color, because right now it's black. We wanted the background color to be white, so we need to fill the screen with that color. All right, sorry, some very loud cars were driving by, so I just took a pause there. What we're going to do now is just update the display. So we're going to say pygame.display.update. So every time you make a change to the display, what you need to do is update it. So in this case, we filled the display, we filled the window with white, which is our background color. And so we need to update the display after that so that those changes actually, take effect. We actually see those changes. I don't know why this is squiggling here, undefined variable pygame. Okay, no problem, that's fine, just because it doesn't see it in this file. Anyways, what we will do now is we will call this draw function from inside of our while loop. So we'll actually do this above the event loop here. We'll say draw, and then actually, do we want to do this above? No, we're going to do this below the event loop. We're going to say draw, and then we are going to pass our window. So we're going to pass win, which we defined up here. So now what should happen when we run the program is we should have a white window. So let's do this. Let's run. And we see that we get a white window that says drawing program. Perfect. Okay, so now we have done that. The next thing that I want to do is I want to start implementing the grid system that we're going to have. So remember, we have all of these pixels, and these pixels are going to be arranged in rows and columns. So really what we should do is create some type of data structure that can hold all of these pixels and specifically what color they're going to be. So what I'm going to do is make something called a grid. I'm going to say grid. Actually, we'll do this a different way. Above this draw function, I'm going to define another function, and I'm going to call this init underscore grid. And what this is going to take is rows, calls, and the color that the grid cubes should start being, or the grid squares should start being. Okay, so inside of this function, what we're going to do is define a list. we're going to say grid is equal to an empty list. And then we're going to loop through all of the rows and columns that we have, and we're going to create the corresponding rows and columns inside of this grid list. This will end up being a 2D list at the end of it, and every single kind of pixel that we have in this grid will be the color that was passed in here. So again, what we're trying to do here is just set up a grid. So I'm going to actually just give you a quick example to make sure everyone's clear here. Let's say we have a 4x4 grid. So 16 pixels in total, 4 rows, 4 columns, all of those are pixels. Then what I would want my grid structure to look like here is the following. Let's move this over. You guys can probably guess where this is going, but I want to have 4 lists inside of my main list. Each of these lists are going to represent a row of pixels, and then inside of these lists, I want every element to be a tuple or tuple, whatever you call it, representing the color of these pixels. So if the color was white, then it would be 255, 255, 255, and then, right, like that, and you would repeat this for all of your rows. So each row would look like this. We would have 16 elements in total, each within their corresponding row, and then the index within the row would be what column they are in. So hopefully that makes sense, but that's kind of what we're going to try to create here, but dynamically based on how many rows and columns we are passed. So in this case, I'm going to say for I, I guess we'd say for I in range, and this will be the len of the rows, or actually not len of rows, sorry, just rows. Then what we're going to do is say grid dot append, and we're going to add a row. So whenever we move on to the next row, we're going to add a row into our grid. We're then going to say for j in range, and this will be all our calls. We're then going to say grid at index I dot append, and we're going to append color. Now let me just look at my cheat sheet to make sure I did this correctly. Looks like I did. Okay, awesome. And I can actually put an underscore here. We don't need the j variable. Another instructive moment here, if you haven't seen this before, in a for loop, if you don't need the variable that you're using for the iterator, you can just replace it with an underscore, and the for loop will still loop the appropriate number of times. You just won't have, any errors or warnings saying, hey, you haven't used this variable. Perfect. So what this is doing is adding all of our rows. Once we add the row, we're adding all of the colors into that row for every single column that we have. Hopefully that's clear. But now that we've done that, what we want to do is we want to return our grid. Awesome. I don't know why I'm getting all of these horrible squiggly lines. I'm going to try to fix this after because this is quite annoying on my eyes. All right, so now we have this function that initializes our grid. So what we're going to do at the beginning of our program is we're going to say grid is equal to init underscore grid, and we're going to pass to it our rows, our calls, and our BG color, because by default, I want all of the pixels to be equal to the background color that we set in settings.py. There you go. We now will have created a grid. So what we want to do now, though, is we want to draw the grid. So let's get on that. So we have the grid, and yeah, we need to draw. So now what this draw function is going to take as well is a grid, and inside of this draw function, we'll draw the grid. But actually, specifically, we're going to make a new function. We'll call this one draw grid. This will take a window as well and our grid, and then this will be responsible for drawing the grid. All right, so let's go inside of draw grid. What I'm going to do is loop through every single pixel that I have. Now, this is a 2D list, so I need to loop through all of the rows and all of the columns and then draw all of the pixels. So I'm going to say for I in, and this will actually be enumerate. So for I comma row in enumerate, and this will be grid. I'm then going to say for j comma and then pixel, in enumerate row. Now, if you don't know what enumerate does, it's kind of a combination of the two styles of for loop. So usually you can say for row in grid, and this will actually give you all of the rows. So it would give you like a row object that has all of the colors in it, right? This is kind of what row would be if you were looping through grid. But sometimes you want the index that this row is at as well as the row. So in this case, you use enumerate, and what that will do is give you, in this case, I equal to 0, and then the actual row that corresponds with index 0 in the grid. Hopefully that makes sense. It's giving you the element and the index of that element in whatever you're looping through. That's what enumerate does. Okay, so for I comma row and enumerate grid, for j, comma, pixel in enumerate row, because now we have a row, so we're going to loop through that row. We're going to get the index of all of those pixels, and then, of course, the color of those pixels as well. Now what we want to do is we want to draw those pixels. So we're going to say pygame.draw.rect. The first argument to this here is going to be where we want to draw this. So in this case, I want to draw on the window. Then we need the color. Now the color is whatever pixel is, right? Because this structure is holding the colors of all of our pixels. So we're just going to say pixel, that will be the color. And then we need to pass a rectangle, which is an X, Y, width, and height. So we need to define the X we're drawing this at, the Y that we're drawing this at, the width, and then of course the height. Now to figure out the X and the Y, we need to know where this pixel is in our grid. Now the way we do that is by looking at what we're at in the current iteration. So if we're on pixel that's in, row 2, column 3, represented by ij, we need to figure out where on the grid that actually is in terms of x, y positions, and then draw the rectangle there appropriately. So I'm going to do the math right now, and I'll kind of, write it in here, then I'll explain how that works. So we're going to start by saying j multiplied by pixel, like this, pixel underscore size, and then I multiplied by pixel underscore size like that. And then in terms of the width and the height, this is just going to be pixel underscore size. Okay, so let me kind of explain how this works. Let me zoom out a bit so you guys can see all of this. So we obviously have a row, and we have a call for every one of our pixels, and that's represented by I and j. If we're on the 0th row, or I is equal to 0, we're on the 0th row, so the very first row. If j is equal to 5, we're on the 5th column, or I guess the 5th index column, which would really be the 6th column. And so to figure out where our cube or where our square pixel should actually be drawn, we're just going to multiply whatever row and column we're on by whatever the size of our pixels are. Now, in this case, the size of our pixels should be, actually, I don't know what the size of our pixels is going to be. It's whatever this division returns. But the size of our pixels tells us where we draw the next pixel, right? If the first pixel is 25 width, 25 height, the next pixel to the right of it's going to be at position 25. Then the one to the right of that's going to be at position 50, then 75, then 100. That's the gap between the pixels, whatever the size of the pixels are. So hopefully that kind of makes sense, but that's what you're doing here to figure out where you're drawing the pixels. And in case you're unfamiliar with the coordinate system in Pygame, 0, 0, so that position is the top left-hand corner of your screen, which means as you go to the right, your X is increasing, and as you go down, your Y is increasing. So let me actually run this, and then I can kind of show you with my mouse a little bit. Missing one positional required argument. Okay, we just need to fix this error quickly. We just need to pass grid to draw. So let's go here and pass grid. That's again because we added grid. We forgot to pass it. So let's run this. And now I can show you. Okay, so up here is the top left where my mouse is. As you go to the right, your X is increasing. As you go to the left, your X is decreasing. As you go down, your Y is increasing. As you go up, your Y is decreasing. So down here, bottom left, would be 0, 800, or 0, whatever the height of our screen is, And to the right, this would be the width of our screen, and then 0. Hopefully that makes sense. And the bottom right-hand corner would be whatever the width of our screen is and whatever the height of our screen is in terms of the X, Y position. Okay, needed to explain that. Hopefully that makes sense. But now that we've done this, we've drawn all of these pixels, we can actually call this function. So inside of this draw function, let's now call draw underscore grid. And let's pass the window, so win, and grid to it. Now, we're actually not going to see anything when we do this, right? Because all of our pixels are the color white, but just temporarily, what I'll do is I'll just change them to be a different color. So I'll just make them black, just so you can actually see that we're going to have kind of that grid being drawn. So let's do this. Let's just run the program. And now notice how we have our white, and then we have this big clump of black. Obviously, all of the pixels are the same color. And so it looks like there's no pixels there at all because they're all the same color, but they are different colors. It just, or sorry, they're not different colors. There are multiple pixels there. They're just all black. Okay, so let's go back here and change this now to say pixel. Okay, so now we'll actually draw whatever the color of these pixels are. Now, the next thing that I want to do here is I want to potentially draw the lines to show you where all of the pixels are. So let's do that inside of here. But remember, inside of settings.py, we have this variable called draw grid lines. So we're going to check in here if draw grid lines. So if that is the case, then we'll draw all of the grid lines. So to draw the grid lines, we need to draw lines for every single one of the columns. So vertical lines, we need a bunch of those. And then we need a bunch of horizontal lines as well. How many do we need? Well, we need however many rows we have, horizontal lines, and however many columns we have, vertical lines. So we're going to do 2 for loops here. We're going to say for I in range, and then this will be rows like that. We'll do something here. And then for j in range calls, and we'll do something here. Okay, so what we're actually going to do is we're going to say pygame.draw.line. Where do we want to draw it? We want to draw it on our window. What color do we want it to be? We're going to make our grid lines black. And then where do we want to draw this line? So now we've passed the screen or the surface. We've passed the color. We now need to pass a starting position and ending position for our line. So the starting position, when we're drawing our horizontal lines, is going to have the same X every single time and a different Y, because we're just going to move the Y down, but the X of the starting and ending position will be the same. So the X's will be at the start of the screen and at the end of the screen, and then we'll just kind of move those lines down as we draw them as we go through the rows. So what we're going to do here is say 0, comma, and then this is going to be I multiplied by pixel underscore size, and then we're going to say width, and this will be j multiplied by pixel underscore size, like that. Okay, so hopefully that kind of makes sense. When I run the program, I'll explain this to you. And sorry, not j, this is I as well. And that's because the y needs to be the same for the start and end position. And obviously the y will change on all of these iterations because it's based on the variable I. Okay, so what I'm going to do is just go to settings. I'm going to change draw grid lines to be equal to true. And now we'll go back here and we'll run this. And let's just see if we are actually getting those horizontal lines. So let's run this. And nope, name rows is not defined. Okay, so I made a mistake here. I can't just loop through the rows because all we're passed here is the grid. So what I need to do instead is say len of grid, or actually now that I think of it, I can just do rows in all capitals because we'll reference that from our settings, right? Okay, perfect. So let's do that. Let's run this. And we get a problem. Name calls is not defined. Okay, same issue. So let's go here and let's make that calls. Okay, so let's run this now. And let's see, there you go. We are getting all of our horizontal lines. All right, so that is working. Now we are going to do all of the vertical lines. So I'm just going to copy this line right here. Paste this here. Let's move this back. And we're just going to need to change this a little bit. So rather than having I times pixel size, this is going to be j times pixel size. Although, actually, now that I think of it, we can just make this I as well. Doesn't matter if this is also I, that's fine. And we're going to have the I times pixel size being the X, because what's going to happen now is our X is going to be shifting because we're drawing the vertical lines, and the Y position of all of our vertical lines is going to be the same. So in this case, the Y is going to be 0. And then the second Y is actually going to be whatever the height minus the toolbar height is. Now, the reason we need to do this is because we don't want to be drawing the grid lines where the toolbar is, because that is not where the grid or the drawable canvas area is, right? So we want to draw it up until the toolbar height. So we take the total height of our window and subtract the toolbar height. And then, of course, that gives us the height that we need. Hopefully that's clear, but that is how you do that. So now if we run this, we should see that this is all good. But notice we're missing one line here. The reason we're missing one line here is because you can see how there's this one line at the very top, right? That line at the very top is when the row is equal to 0. So what we actually need to do if we want to make sure we get a line at the very end here, you probably can't really see it, but we're missing a line at the very end and the line at the bottom, is we just need to add 1 to our rows and add 1 to our calls, because since I starts at 0, the first line we draw starts at 0, right? It starts at position 0, and so we need to account for that and make sure that we add 1 to this so that we actually are going to draw the line at the very end. We're not skipping that last line. I'm sure that was a horrible explanation, but that's the best I can give you. Just add 1 to this. It will fix the problem. So let's run this. Okay. Now you can see we are getting our final line being drawn. Perfect. Okay, sweet. So now we have that. The next thing we need to do is we need to make some buttons for some different colors, and we need to allow the user to actually draw. So before we do all of the buttons, the first thing I think we should do is just make it so you can draw black on the grid. So just one text color or one pen color, sorry. And then what we'll do after that is implement all of the buttons and change the drawing color. Now, since we know we're going to have multiple drawing colors, let's set a variable here called drawing color. And let's make this equal to black to start. And then what we can do is use this. So whenever the user actually clicks on a cube, we'll just draw with whatever the drawing color is. And the way we'll draw is we'll just change the color of the pixel that we clicked on to be whatever the current drawing color is. So what I'm going to do is go inside of this event loop here, because inside of this for loop is where you check all of the events that occurred. And we are going to see if the user has pressed their mouse. So actually, let me make sure this is correct. Yes, it is. Okay, we're going to say if pygame.mouse.get_pressed, and then we are going to put 0 here. So what this does when you say if pygame.mouse.get_pressed is it gives you whether or not the user pressed the left, middle, or right mouse button. So if you want to check if they pressed the left mouse button, then you do 0. So that's left click. If you wanted to check if they did the right mouse button, I'm pretty sure that's 2 because I believe it goes left, middle, right. So index 1 would be middle and 2 would be right. But I only care if they press the left mouse button. So I'm going to say if pygame.mouse.get_pressed, index 0, checking if they press the left mouse button. Then what I want to do is I want to figure out what pixel they pressed on, or if they pressed on a pixel. And then if they did, I want to change the color of that pixel to be the drawing color. So this is where we now need to figure out, how do we know what pixel the user pressed on? Well, we are able to get the position of the mouse. So we can say pause is equal to pygame.mouse.get_pause. And this gives us the XY position of where the user pressed their mouse. So given the XY position, we should be able to figure out what pixel is at that position, or what pixel we pressed on. The way we do that is we make a function, and we're going to say define. And what did I call this function here? It's going to be get_row_call_from_pause, because we have the XY position, but we want to know the row and the column of the pixel that the user pressed on. The reason we need to know that is because we have to access that in our grid and change that color. And so this is going to take a position, and then here we will return to the user whatever XY position it is that they pressed on, or sorry, whatever row call position is they pressed on. So what we're going to do here is we're going to say x comma y is equal to position. This is going to decompose this tuple, give us the first thing as x, second thing as y. We're now going to say the row is equal to, and this is going to be, should be at least, x integer divided by, and this will be the pixel underscore size. And then for the call, this will be the same thing. Call is equal to y integer divided by pixel underscore size. And then we will return row comma call. Let me make sure that's right. Looks like it is. Okay, let's explain how we get this. All right, so let's just take a simple example here to understand how this works. Let's say we are at position 9, 4, and we have a pixel, oops, if I could type this, underscore size that is equal to 5. So the pixel is 5 width, 5 height. What position am I at, or what row column position am I at when I'm at 9, 4, x, y? Well, the way you figure this out is you take 9 and you integer divide it by 5, and that gives you 1. Now, when you do an integer division, this is simply removing the decimal from whatever the division would normally be. So in this case, what would you get? You get something like 1.8. In this case, you just remove the 0.8 and you get 1. Okay, then we take the 4, we integer divide by 5, that gives us 0. Usually that'd be 0.8. You strip off the 8 right, and that gives you a 0. So this tells us we are at column 1, row 0, which would be the correct pixel that we're at. The way that we know that, or the reason that we know that, is because each pixel is a certain size, right? And so if we're at position 9, 4, that means that we must be at this pixel. It's really hard to give more of an explanation than this. You kind of just have to visualize how this would work, but I just wanted to show you that that's how this would work with a pixel size of 5. You can apply this formula, obviously, with any pixel size in any position, and this will tell you what row and what column you're at. Now, the only thing to consider here is that we cannot press a pixel that is in the toolbar, right? We have that little toolbar area, which is not an area where we're able to draw. So we need to actually ensure that the row that we have is not too low. It's quite possible we could have a row that is greater than 50, right? If we have a row that's actually 50 or greater, that means that we pressed somewhere that was not in the drawable area, that was in the toolbar. So what we're going to do here to check this, to make sure we did not click somewhere that's not in the drawable area, is we're going to say if row is greater than, and this is going to be rows, sorry, greater than or equal to rows, then what we're going to do is we're going to raise an index error. Now, it's fine. You don't need to know why we're raising the index error. Essentially, I just want to raise an error, and then we can catch this error in another place in the program to tell us, hey, we actually ended up pressing somewhere in the toolbar. We weren't pressing on a pixel. So this is just to indicate to whatever calls this function, hey, we did not actually press something that was in the drawable area. So this is how you raise an exception or an error in Python. Maybe you didn't know that. Now you do. Okay. So now what we want to do is after we get the position of our mouse, when we press the mouse, right, we want to figure out what row and what column we're in. So we're going to say row call is equal to, and then this will be the name of our function. So get row call from pause, and then we'll pass our position. Now, what we need to do, though, is we need to put this inside of a try statement. So we're going to say try, and we're going to say except index error, and then here we will do something else. Now, the point of this is that we may potentially raise an error if we pressed somewhere that was not in the grid. And so we need to catch that error. That's what we're doing here. We're accepting it. But if this is non-error, so this works fine, we don't raise an error, then what we will do is we'll change the pixel color. So we'll say grid at row call is equal to drawing color. There you go. So hopefully that makes sense. We're getting the position of the mouse. If we left click somewhere, then we're figuring out what row and call we pressed on. If we did not press on a valid row and call, we're just going to accept that error and just continue the program. We'll do something else here in a second. And then otherwise, if we did not get an error, we had a valid row call, we will change the color of that pixel. All right, so let's run the program here and see if this is working. Okay, so immediately this is not working, and I think I know the problem. I believe I mixed up the row and the column. So you can see it is drawing stuff, which is not based on where my mouse is. Okay, this is because I accidentally mixed up X and Y. So just swap these, sorry. For the row, we need to use Y, and for the column, we need to use X. Okay, my apologies on that, guys. So swap X and Y in this function, and we should be good now. It's just returning to us the wrong value. So let's try this. And now, okay, there you go. Correct. So now we're actually pressing in the right square. And what happens if we press in the toolbar? Well, obviously nothing is happening because it's throwing that error, raising that error, and then we're catching that error and making sure, obviously, it doesn't crash the program. Sweet. So now we can draw, right? There you go. We've got the core functionality of the app done. What we need to do now is be able to change the color. So we need to implement some buttons. All right. So now we are moving on to do our buttons. So remember, I made this button file. This is where I'm going to put a class that we are going to use to represent all of our different buttons. Those buttons are going to be, you know, the black button, the red, the green, and the blue button for the different text that we can have, the clear button, and the erase button. They'll all be represented by this class. So inside of here, I'm going to say from, dot settings, import star. I just want to import all the stuff from settings. And since I'm inside of the package, I import it this way. Then what I'm going to do is say class button. I'm going to set up my init. So define __ init. And then I'm just going to type this out. There's quite a few things that we want to take here, but we want an X, a Y, a width, a height, a color, some text. Optionally, we don't have to have text. And then optionally, again, some text color that will default equal to black. All right, so if the user passes some text, that tells us that, hey, this button has text on it. And then, of course, we'll look for the text color as well. But by default, we're going to assume the button that we have is not a textual button. It just has some color on it. And so in that case, we only care about these 5 things. But of course, we can pass some text as well. So now we need to do this. Self.x equals x, self.y equals y, self.width is equal to width, self.height is equal to height, self.color is equal to color, self.text is equal to text, and self.text color is equal to text color. All right, so if you're unfamiliar with what I'm doing right now, I'm not really going to explain OOP. It would take a really long time to explain what all of this stuff is actually doing. I do have a video on my channel that goes through OOP, object-oriented programming. That's what OOP is. And so feel free to follow along with that. Again, I'll leave a link to it in the description and some card. If I forget, please do remind me because there's a good chance I might do that. Okay, now we've initialized all the stuff that we need for this class. We're going to define two methods. The first method I want is draw. This is going to take self and win. And the next method I want is going to tell me if the user has clicked this button. So it's going to be called clicked. And we're going to take self and pause. And the pause will be the mouse position. And then this will return to us whether or not this position is on this button. So did this position click this button? Essentially, is this position inside of the rectangle that represents this button? That's what clicked is going to tell us. So it's just going to be a really easy way to determine whether or not the user pressed this specific button. Anyways, let's start with the draw method. So inside of draw, the first thing I want to do is draw a rectangle that is the color of whatever color we passed in here. And that is obviously at position XY and has width height. So let's do that. We're just going to say pygame.draw.rect, and then this is going to go on the window. This is going to have a color of self.color. This is going to be on self.x, self.y, self.width, and self.height. Perfect. So we're just drawing a rectangle. We've seen this before. Again, passing the color, passing the rectangle we want to draw. So x, y, width, height, position. Next, we're going to check if there is text for this button. So we're going to say if self.text. Now, when you do this, if you say if self.text is not equal to none, then this condition will be true. If it's equal to none, it will be equal to false. So if we have text, then we need to do some extra stuff. So we're going to say pygame.draw, like this, pygame.draw.rect, and then we are going to do pretty much the exact same thing as here. So let's actually copy this. But this time, what we're going to do is we're going to change the color so that it is black. And we're going to make this rectangle not filled in. And sorry, I don't need a V there. And to make it not filled in, we're going to pass the width of 2. So the last optional argument here when you're drawing a rectangle is the width of the rectangle. If you pass any value to this, what this will do is make it so that the width of the rectangle, it will make it so that the rectangle has an outline and it's not filled in. So what you're drawing is literally just a rectangle. It's not filled in with the specific color. It's just going to have whatever color you put here as the outline of the rectangle. Hopefully that kind of makes sense, but this is just going to draw a 2-pixel outlined rectangle that doesn't have any filled in color. And the reason we're doing that is because when we have text for our button, then we want to draw the text inside of the rectangle. And so what we're doing is we are drawing the color of the rectangle, right? So this draws the filled in rectangle. Then if we have text, we're drawing an outline for that rectangle. Then we're drawing the text on top of the rectangle that we've done here. The reason we could do an outline for regular buttons as well, but I think it just makes sense to do an outline when we have text and not do an outline if we don't have text. But if you want to do an outline in both situations, then you would just do this. Make sure you do the outline after you do the filled in rectangle. Otherwise, the filled in rectangle will cover the outline. Hopefully that makes sense. And in fact, let's leave it like this. We'll just have all of our buttons have an outline. And then in the situation where we have text, what we need to do is draw that text. So remember in settings.py, we have this get font function. And what this does is return to us a font object that we can use to render some text. So what I'm going to do here is say that my button underscore font is equal to get font. And then I'm going to pass the size that I want. And in this case, I'll pass the size of 22. Experiment with whatever font sizes you want. 22 will work well, though, for the size of the buttons that we're going to have. Okay, then I'm going to say that my text surface is equal to my button font dot render. So what you have to do when you want to draw text in Pygame is you have to create this font object, which is what we've done with this function here. And then you have to use that font object to render text. So I'm saying text surface is equal to button font dot render. I pass the text I want to render, which is self.text. You pass 1 here, which is the anti-aliasing. Don't worry about that. Just pass 1. I'm not going to explain what that is. And then the color will be, of course, whatever the text color is. So self.text color. Okay. Now that we have the surface, we actually have the rendered text, we need to place it onto the button. We actually need to put it onto the screen. And so the way you do that is you do win.blit and then text surface. So what this function is doing is using the window to blit or place another surface on top of it. So I won't get into too much depth, but in Pygame, anything that's you can like draw on is called a surface. So in this case, this gives us a text surface. And so we're just blitting that onto the screen. Don't have to worry about that too much. And then what you pass after this is an X, Y position of where you want the top left-hand position of this surface to go. So I should have mentioned that previously, but whenever you draw something in Pygame, it draws from the top left. So when I draw a rectangle, right, I pass my X and Y, that's the top left-hand corner of where the rectangle starts drawing. And then of course you have to add the width and the height to figure out how large the rectangle is going to be. Okay, so we have text surface, but now we need to figure out where are we actually drawing the font. And I want the font, or I want the text, sorry, to be directly in the middle of my rectangle. Now, I'm just going to do a bit of fancy math here. I'll explain how that math works in a second, but just follow along with me. This will make it so it goes perfectly in the middle. So I'm going to say self.x plus self.width over 2 minus, and then this is going to be text underscore surface dot get underscore width over 2. Let me just save that. And then for the Y position, it'll be the exact same thing, but just with Y. So self.y plus self.height over 2. And then this will be minus text underscore surface dot get underscore height over 2. So let me just explain what this is doing. So really, we just need to pay attention to one of these because the other one's the exact same, just in the opposite direction. So we're taking our X position. We are adding the width over 2 by it, right? So that is going to be the direct middle of our button. If you take the width of our button divided by 2, and you add that to the X position where the button starts, that's directly in the middle of the button, right? Hopefully that makes sense, but that should be clear enough. Once you've done this right here, you're directly in the middle of the button. So then what is this part? Well, the thing is, I'm drawing my text from the top left of that text. And so if I draw just right in the middle of my button, what's going to happen is my text is just going to draw to the right of the middle of my button. And so it's not going to be in the middle of the button because I'm going to be drawing it the top left of my text right in the middle. And so what I need to do is move that back a bit. So I need to go from the middle to the left a bit so that way I'm kind of offsetting where I'm drawing the text so it happens right in the middle. So let me go to a little bit of a drawing thing here. Do I even have... I keep losing my Windows Ink. Let's see. Can I go to Windows Ink? Windows Ink? No, not workspace settings. Let's just go to Paint. I'll do it in Paint. Okay, so let's say we have our rectangle, okay? This is in the middle. If I draw my text here, right, then it just goes on the right of the button. I don't want that. So what I need to do is take whatever the width of my text is, divide that by 2, and then use that as the offset of where I start drawing my text. So if I redo this now, if we say this is the middle of my button, then what I'm going to do is I'm going to draw my text here so that when I start drawing it, excuse me, I'm with my mouse, it's going to be right in the middle. Hopefully that makes sense, but I'm getting half of the width of the text, subtracting that from the middle position of my rectangle, and then that's where I start drawing the text that it appears directly in the middle. Now you can apply the exact same logic going in the horizontal direction. So you can say that's the middle. We're going to draw, up like that, right? So take half of the height of the text and subtract it, and that's where we start drawing the top left-hand corner. Hopefully that kind of makes sense, but that's how that works. Okay, so that will draw it directly in the middle, and then I think that's all we need actually for the draw method. The next method is to check if we clicked on this button. So I'm going to say xy is equal to pause, and I'm going to say if not, and then inside of here, I'm going to say self.x, or I'm actually going to say, sorry, x is greater than or equal to self.x, and x is less than or equal to self.x plus self.width. Then in this case, I'm going to return false. Again, I'm just going to write all of this and I'll explain it after. I'm going to say if not, y is greater than or equal to self.y, and y is less than or equal to self.y plus self.height, return false. Otherwise, I'm going to return true. Okay, I know I went quickly. You guys feel free to pause, obviously. I'm sure you guys have been doing that and fill this out. But what I'm checking is this condition. So ignore the not for right now. Just think about what this condition is doing. I'm checking if the X position that I have is greater than or equal to, so whatever X position is past, right? Whatever my mouse position is, I'm checking if that's greater than or equal to whatever the X position is of my rectangle, because all my buttons are rectangles here. And then I'm checking if the X is less than or equal to whatever the self.x plus the width of my rectangle is. So I'm pretty much checking, hey, is my X within the X of the button? Is it greater than or equal to the X, but less than or equal to the end of my rectangle? That's this position here, self.x plus self.width. That gives you the X position of the very end, kind of the right side of the rectangle. So I'm saying if this is not the case, if I'm not within the X bounds of the rectangle, return false. Now, same thing here for Y. Just flip this around. We're now doing this in the vertical direction rather than the horizontal direction. We're checking, is the Y position greater than or equal to the Y position of the rectangle? And is the Y position less than or equal to the bottom position, the bottom Y position of the rectangle? If that's not the case, then return false. Otherwise, we return true. We did our 2 checks. Yes, we have clicked this button. Okay, that's about as much of an explanation I can give you there. That is how you check if you pressed the button. Okay, now we have this button class. We want to use this button class. So what we're going to do is we're going to set up a few buttons. We're going to say buttons is equal to, and this is going to be a list that's going to store all of our buttons. And inside of here, I'm going to say button, and then what I'm going to do is define my first button. So let me just look at my cheat sheet here because I don't want to come up with this on the top of my head. I have all the math kind of pre-done. We're going to draw our first button at the position 10, and then height minus toolbar height over 2, and then this is going to be minus 25. I'll explain how we're getting this for the Y position in 1 second, but I'm just going to copy this and make this button underscore Y, just so we don't have to write this a bunch of times, because we're going to use this for all of the Y positions of our buttons. We're going to say button Y. Then for the width and height of our button, I'm going to make this 50. So the reason why I'm subtracting 25 here is because the button width and height is 50. So what this is doing is it's saying, okay, let's figure out where the toolbar starts. So we're taking the height of our window, we're subtracting the toolbar height divided by 2. What that's going to give us is the direct center of the toolbar. Same thing as when we were drawing the text in the middle of the button. If you just look at this, this will give us the middle Y position of the toolbar. Then I'm subtracting 25 from it because I know the height of my button is going to be 50, so I want to draw it 25 pixels higher than higher than the middle of the toolbar, so that way when I draw the full height, it will be directly in the center. Hopefully that makes sense, but that's how you come up with the Y position. So 50-50 for width height, and then the first color I'm going to have here will be black. Now we can literally copy this exact same thing, and all we need to change now is the X position. We'll copy this a few times, and the color. So we'll have black, and then this will be red, green, and blue. And then in terms of the X position, I know that each of my buttons have 50 width. And so what I'm going to do is just have 10 padding, so 10 pixels in between each of my buttons, which means that this is going to be at position 70, right? So I'm going to add 60 pixels each time to account for the fact that the last button was 50 pixels long and I have 10 in between each pixel. So now I have this will be 130. This will be 190. And then we're going to have 2 more buttons, one for erase and one for clear. So in this case, these buttons are both going to be white. So we're going to put these to be white, and then their position, this one will be 250. Yeah, I think that makes sense. And this will be 310. But then for these last 2 buttons, I want one that is erase and one that's clear. So the text for this one will be erase. This one will be clear. And then the text color will be black for both of these. Perfect. So now we have all of our buttons. So let's just start by drawing the buttons and just seeing what they look like. So we put them all inside of a list. So what we're going to do now is we're now going to pass our buttons to our draw function. So we'll add a parameter here to draw. And what we're going to do is before we update the display, we're going to loop through all of these buttons and we're just going to draw each one at a time. We're going to say for button in buttons button dot draw. And we need to pass our window, so we'll pass win. That's as easy as it is to draw all of our buttons. That's why having the class is nice, because now all of this kind of, messy stuff is taken care of in a different place. All we do is just call the draw method, and there you go, our button is being drawn. So let's run this and let's see if this works. Okay, we got an issue. Name button is not defined. This would make sense. We need to go inside of init.py. We forgot to import button. So inside of here, I'm going to say from, this would be dot button import and then button like that. We could do an asterisk, but there's only one thing we want to import. So I'll just manually write it like that and save. And that should be good. Okay, let's go back to main.py and let's run this. All right, and there you go. We now see our beautiful buttons, right? Now, when I click them, nothing happens because we haven't done that yet, but you see that we have all of our buttons showing up on the screen. So now we want to handle actually clicking these buttons. So the way we're going to do that is we're going to go here and we're actually going to write something inside of this index error kind of except statement. So remember that we get this index error from this function here when we press something that's not in the drawable area. And the only other area that's not the drawable area is the toolbar. So we know that if we got an error, we must have pressed something in the toolbar. So inside of this except statement, what we can do is check if we pressed any of our buttons. So all we'll do is loop through all of the buttons and check if we pressed any of them using the nice method that we set up on those buttons. So inside of here, we're going to say for button in buttons, and we're going to say if button dot clicked, and then this will be when, no, not when, sorry. We're just going to pass our mouse position. So if button dot clicked pause, that means we actually clicked the button. Now I'm actually going to say if not button dot clicked pause and then continue. This is a nice little shortcut here for you. So shortcut trick, I guess is a better word for it, to avoid having a bunch of indentation levels. So I'm saying if not button dot clicked pause. So if we didn't click on the button, continue. So just go and check if we click the next button. What continue does is just bring you back to the beginning of the for loop or to the next iteration of the for loop, sorry. But under here, so if we did actually click on this button, what we're going to do is we are going to set the current drawing color equal to whatever the color of the button is. So we're going to say drawing underscore color is equal to, and then this will be button dot color. So this will work for all of our buttons except for the clear button. I'll show you what I mean by that in 1 second, but this is pretty straightforward. We're looping through all the buttons. We're checking if we click them. If we didn't click them, we'll just go and check the next button. If we did click them, then we're going to simply set the drawing color equal to button.color. And we can actually break because there's no point in checking the other buttons if we know we just pressed this button. If I press this button, there's no way I pressed another button. Although we could if we had overlapping buttons. So maybe we'll remove the break just in case for some reason in the future we have buttons that are overlapping with each other. But for now, this is fine. Okay, so let's just try this now. And as I mentioned again, this will work for all of the buttons except the clear button. So let's do this. Now when I press red, notice I start drawing in red because I changed the drawing color variable to be equal to the color of the button that I pressed on. Now if I press erase, this works too. Why does erase work? Well, erase works because the color of erase is white. So when I press on erase, what happens is I'm not actually like erasing these pixels. I'm just drawing over them with white. That's kind of what we're doing. And since the background color is white, well, there you go. That's how it works, right? And we can go to green. Green works, but clear is just another erase, right? When I press clear, it's doing the exact same thing as erase because we haven't implemented anything for clear. So that's what we're going to end off with now, just checking the clear button specifically. So what we can actually do here is we can say if the button dot text is equal to clear, then we can simply reset the grid. So actually, let me put this above here. So we'll put this above like that. Okay. And we say if button.text is equal to clear, then what we're going to do is say grid is equal to init underscore grid. And in fact, we can just copy exactly what we did the first time we created the grid. Where did I make the grid? Right here. So let's copy this. All we're going to do is clear the grid. The way we clear the grid is we just remake it, right? Just make a brand new grid that's going to be filled completely with white squares, and then we should be good to go. Now, the only thing we need to do after this, though, is we just need to change the drawing color to be equal to black, just to make sure that when we start drawing again, we're not accidentally having like the erase thing being enabled, right? Because it'd be weird if you cleared the screen and then you were automatically in erase mode. You don't want to do that. You want to be in drawing mode after you clear the screen. At least that's the way I want to do it. Okay, so now that we've done this, we're checking if the text of the button we pressed on is clear. And if you wanted to add other buttons that had special functionality, this is the way you would do it. You would just check if their text is equal to something, or you could add some property on the button and you could check that. But that's kind of how you would go about doing it. So let's run this and let's see what happens now. Let's draw something. Let's press clear. Boom. Clears the screen, right? Okay, let's press something. Press clear. Boom. Clears the screen. And with that, that's going to conclude this program. So as I promised you guys, I will mess with some settings here just to show you that the way we've programmed this is dynamic. So the whole reason I've gone and used all these variables and maybe to some of you made it a bit more complicated than it needed to be is so that I can go here at any point in time and change something and the program just adapts. It just knows how to work. Everything is based on variables. There's no hard-coded values, at least very few hard-coded values. And so if I go here and I change this to false now, draw grid lines, right, as I promised. Oops, I need to run main.py. You're going to see that now we don't have grid lines, right? And I can still draw just like I did in that previous demo. So that's an example of one setting you can change. Another setting you can change is the pixel size, right? So let's change this to be 10. So 10 rows, 10 columns. Now, if I go to main.py and I run this, notice that my pixels are much larger, right? So obviously probably not the best in terms of actually drawing stuff with this, but you can see we have larger pixels. We've changed the pixel size. Nice. Okay, let's go back to settings.py. We could, you can change the background color. If you change the background color, I'm not gonna do that, but you guys can mess with that and see what that does. Let's just make these 100 and see what happens if we make them 100 and draw the grid lines. Let's go true. Let's run this. Okay. Now, obviously, we have much smaller pixels, and you can see it can't even keep up with me hitting the mouse. So if this is the case, right, notice how it can't even keep up with my mouse, like it's missing a lot of pixels. What you could do is you can increase the FPS. So if I make this 120, we'll see if this actually works or not. This might just be a limitation of Pygame, but okay, you can see that works a lot better now when I increase the FPS. So if you make the FPS even larger, let's make this like 240. Let's see here if this works any better. Okay. Yeah, okay, so now you can see it's pretty much working. I mean, if you go really fast, it can't keep up. But if you go at a moderate speed, then it can keep up with a higher FPS. I don't know if the FPS is really making a difference, but that is something that would potentially change it. The reason why the FPS going up would make this work better is because this allows you to do more events per second, essentially, to refresh the screen more often. And so you can check more events. That's kind of the reason why that might do something. All right, with that said, though, I think I'm going to end it here. Hopefully you guys enjoyed this video. Hopefully this showed you kind of how to set up, a relatively large program. Obviously this isn't massive, but you can see we've used a few different files. We're importing modules. It's pretty nice and organized and clean. We don't have tons and tons of lines of code in each file. It's pretty easy to figure out what areas of our code are doing what. You can see we have this kind of package module system that I'm sure is probably new to a lot of you guys. Hopefully that helped you learn something. We've used a class, right? We've done a bunch of different things, again, with the purpose of being kind of educational. All right, so hope you guys enjoyed. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another one.